fifth read. Do we get the fifth read now here? Can I able to see the data here?
No, sir.
So why means without, I mean, once the sequence was handed over to the drive, once the last sequence was handed over to the sequencer, my sequencer is giving the things to the driver. Once it got done, my start tells like, yeah, everything got done. So it informs that yeah, all sequences got done. Immediately, objections got dropped. Okay, once it will tell, actually the start method will tell once all the sequences got completed. Okay, so once this got completed, it immediately goes to the next statement, that is drop objections. So once it got dropped, okay, almost all at the same time dollar finish is also getting called, right? Right, so that is what we have discussed, right? So once this got called, run phase got completed, so immediately what it will do is cleanup phases will get start, all our functions, so it will get execute, it will get executed at the same time. All cleanup phases got executed at the same time. So what is the time here? Assume it's around like, so all these are in picoseconds. Okay, go to the time frame and change it to nanoseconds. So it's around like 205 nanoseconds kind of thing. Assume somewhere around here at 210 nanoseconds. At 210 nanoseconds, what it is happening is this one at 210 nanoseconds, the simulation is actually getting ended. If you see 210 nanoseconds, 210 nanoseconds, at 210 nanoseconds, objections got dropped, all cleanup phases got executed, dollar finish got called at 210. So that is the reason at that time we are not able to see the exact value at that time. Okay, so that is the reason I need to give some delay before dropping the objections. I need to give some delay. Okay, let's take like 100 nanoseconds. This 100 is not fixed value. This is based on how much time my driver and my DUT, design under test, is actually taking the things to get driven properly and everything. Okay, so that much time we need to give here. As a kind of thing, I have just given 100 because for me it will take more than 10 to 15 seconds, 15 nanoseconds. So that is the reason I am taking it like a huge time as 100 nanoseconds. Now let's execute this one. So right now it is ending at 210 nanoseconds. So now let's see, it need to end at 310 nanoseconds because I have given 100 nanoseconds extra. So 310 nanoseconds. Now if you go to the waveform, it got all the way, all the data, right? So previously it was 210 nanoseconds. 210 nanoseconds here. Okay, somewhere around here. So now it has ample of time, so my design is responding according to that and it is giving. So now what is happening here is it is actually telling that once the sequence got completed, we are waiting for 100 nanoseconds and then we are dropping the objections, right? So this is hard coded value, so the calling of the drop objections itself happening at after 100 nanoseconds. Did everyone accept this? Line number 124, this will going to end at 210 nanoseconds. So after 310 nanoseconds, this will get called at 310 nanoseconds. Okay,
Yes, sir.
so now I am waiting here 100 nanoseconds. So instead of that I can say one more thing, phase dot phase done dot set drain time. So in this class I am setting and the drain time as 100. This also will give me 100 nanoseconds delay only. This will give 100 nanoseconds delay. But what it will do is like immediately it will get set and this will going to happen at 210 nanoseconds itself. All these things will going to happen at 210 nanoseconds itself. Okay, Once the completion of all the data, once the completion of all the phases happened, so from, I mean, once the final phase got completed, from there it will start waiting for 100 nanoseconds, and then it starts executing or it starts calling the dollar finish. Got it? Got it? So this is going to happen at 210 nanoseconds only. Okay. But at the 210 nanoseconds, what happens is 210 nanoseconds, all the cleanup phases also got started. So once the cleanup phases happened, then this 100 nanoseconds will get called, and it will wait for 100 nanoseconds, and then the dollar finish will get called. So that is the reason it doesn't matter whether I will put here or here or here. It doesn't make any sense. It doesn't make any difference actually. Okay. Even you can put like this. That's also fine. So I am telling that I am telling to the root that okay, right now objections got dropped. That means all the run phase for this test n write n read without drain time got completed. Okay. Now once this got completed, you need to wait for 100 nanoseconds. That is what this one is all talking about. So phase done is nothing but it is the instance name of UVM objection. Okay. UVM objection is a class. So for that UVM objections, the instance of UVM objections in the UVM phase is phase done. So inside that there is a method called set drain time. So I am calling that set drain time. Okay. So inside UVM phase, we have UVM objections that got instantiated as UVM, sorry, phase done. Okay. Phase done. So if you see, UVM objection is instantiated as phase done. So what is this UVM objection? UVM objection. So this is what UVM objections, and it is a class. Okay, it is a class. So now inside this it has some methods. Okay, so which are not relevant for us right now. Okay, so one of the method I am using from this is like set drain time. Okay, set drain time. Okay. So set drain time and the given object to the drain, this time amount of time wait once all objections has been dropped before calling the all dropped callback and propagating the intent to the parent. Okay. So once all objections got dropped, then it will wait for that much of time. Okay. So here we need to give UVM object type, and that means who is dropping or who is setting this drain time, and time is how much time. Okay. That is what the things are like. Okay. So this is what we are calling UVM phase. We will get that UVM phase from here itself, the phase variable. This is local to this run phase. Okay. So phase dot phase done, it is nothing but instance name of UVM objection. So inside that we have set drain time. So who is setting this class? That means this class is setting the drain time as 100. That is what the things are like. Once all the objections got dropped, okay, all components objections got dropped, then it will wait for 100 nanoseconds. Got the difference?
Yes, sir.
Just with the drain time. Right now I'm removing this one and this one. Yeah. So with drain time done. So any doubts in the UVM objections? If it get if dollar finish get called automatically, last data may get loose, may get lost. So we need to set some drain time to properly transmit the data. Okay. This drain time is based on the time that requires, how much time that requires to transfer the data from test bench to design and vice versa. Okay. Transfer the single data. Okay. Or based on that we need to set the time. For example, one transaction requires 10 nanoseconds. So I can set drain time as greater than or equals to 10 nanoseconds. Okay. So based on that. So for that reason, we'll put some bigger number. So instead of 10 nanoseconds, we will put some bigger number. That is 100 nanoseconds. Okay. Like that. So for this, we have a method called set drain time in UVM objections class. So objections are raised on phase. So that phase is local to every function, every phase, every method, every phase method. Okay. Select phase methods. Fine. Syntax. Raise objection. Raise objections. Phase dot raise objections. It's not objections, it's objection. So who is raising this? Okay. Next. Drop objections. Drop objections. Okay. Set drain time. Phase done dot set drain time, this comma some time. So once this drain time, once all the phases got completed, then root will wait for 100 nanoseconds. Got it? This is what the objections are all about. Okay. Any doubts in the objections?
No, sir.
Okay. So now let's see sequencer mapping. Okay. So sequencer mapping. So where the sequencer is getting mapped in the with the sequence. Okay, it is actually happening in the. Can anyone tell me where we are mapping this? Just do a rough guess where we are mapping this one. Can anyone do a rough guess like where we are mapping this one?
In base test, sir.
In
Compare.
not in base test, in every test except base test. Okay, because
No.
base test, which is common to everything, we'll put on the base test. Okay.
Yes, so whatever the test we extend from the base test, the base cases we want to write.
Hmm.
Using with the start, sir. Sequence dot is start, then
Mm,
sequence.
yes. With the help of that start method, we are mapping the sequence to the sequencer. So let's try to understand how the things are going to happen. Okay. So first, I'm giving like what is the, I am telling like how a entire transaction we flow from sequence to the DUT and everything. Okay. This is our sequence library. Assume it has multiple sequences. Okay. And this is my sequencer, this is my driver, this is my DUT. Okay, and this is interface. So like this, like this. Yeah. Sequence library, this is nothing but our sequence lib. Okay, it has sequence write, sequence n write, sequence write read, n write, n read. Okay, so these are the things we have. Okay, so now this is my sequencer, this is my driver, this is sequence item port. Okay, sequence item port, this is sequence item export. sequence item export. Okay, so let's mention that sequence item what sequence item export. This is interface, and this is DUT, design under test. Fine. So now what happens is, like, first how the things are going to happen, let's see. So what happens is, my driver will ask an item, okay, through TL imports. That is called as get next item. So this is the first step. Okay, step 1, that is get next item. Okay, get next item, this is the step 1. Get next item. So for this step, this is the first step. Sequencer, assume we are working on sequence and write, assume. Okay, so sequence will take that. Okay, this is the second step. So I am not actually mentioning lot more methods. Just for the easy understanding, I am just drawing the things. Even if you ask me, I need to wait for a grant here. Next, after that, some kind of things, some kind of methods are there. Okay, send request. After that, wait for the item done, kind of things that I am not mentioning here. I am just showing the flow. Till now, whatever we have used, I am just using that flow. Okay, so it will take one sequence, and that sequence will present at the sequencer. Now that sequencer will give the transaction to the driver. Now what this driver will do is, like, this driver will drive the things to the interface. Okay, so interface, and this is the fourth step. Okay, next next once this got done, it will tell to the sequencer that this is the fifth step. Okay, so fifth step, it will tell like item done, item done with some response. Okay, item done with some response. So once with response happens, okay, that response is gets stored in the queue that was there inside sequencer. Okay, this is a queue. This is a bounded queue. Okay, bounded queue. So locations, total number of locations are total locations 8. Okay, so this is a bounded queue. Inside this bounded queue, these responses will get collected. Okay, will get collected. 8 responses. So now what happens is, now my sequence, okay, my sequence will actually try to get that response with the help of a method called get response. Okay, get response. The get response is the method. With the help of get response, these responses will be handed over to the sequence. Okay, So this is how a communication will generally going to happen. First, driver initiate by giving by using get next item. So after that, my sequencer will get grant, and then it will start randomizing the things. Once randomization is happening, that will put that into the send transaction, I mean send request. Okay, then it will go here kind of things. Okay, after that there are a lot more steps happen, pre-do, mid-do, and lot more steps happen. Let's not go into that complex things here. So next what happens is like, the sequencer will give the transaction to the item to the driver through TLM ports. So now the driver will drive that to the interface. So once this driving got completed, it will tell that item done. So till that time, my sequence is actually waiting. Okay, waiting for that request. I mean, waiting for item done. Actually, there is a task call is happening inside that. So that all can be taken care by the UVM do with or UVM do. That will take care of everything. So whatever I told just now, wait for request. Okay, sorry, wait for grant, send request, and next wait for item done, and everything. Okay, will get taken care by two things. One is start item and finish item. That two things will also taken care by UVM do with. So that is the reason we are directly writing that UVM do with or UVM do. Okay, instead of writing that individual tasks or functions. Okay, so if my sequence requires any kind of response from the driver, or my driver need to communicate with the sequence. Okay, not sequencer. Okay, with the sequencer, but there is no direct connection between driver and sequencer. I mean direct connection between driver and sequence. So through sequencer only, my driver will communicate with the sequence, that too with the help of this response. If I don't give this response, in the sense this sixth step won't available. If I give response rsp in bracket item done, then the sixth step will present. So my sequence will take that response, will collect that response is nothing but that is one of the sequence item. Okay, so that will get collected here, and based on that response, my sequence will generate a next item. Okay, got it? This is how a sequencer things will going to happen. The whole transaction will get happen. Did everyone understood this? Did everyone understood this?
Yes, sir.
So first, tab new main driver. So this will get called get next item. So immediately sequencer will take sequence. Okay, and it will hand over to the driver. Okay, now it got the request. Okay, so this request is getting driven. Okay, once that got done, once that got driven. Okay, now my sequence, my driver is telling that item done. If I don't give any response here in bracket, if I don't give any response, then that sixth step is the sixth step won't happen. If I provide response, in the sense here if I write rsp, okay, then automatically the sixth step will get present, and automatically it will take that response, and based on that response it will start working, or working in the sense start creating a new sequence. Got it? Got it? This is the request. If you ask me, this is the request req. This is the req, and this is the rsp, request response. Got it? This is what the bidirectional things, which is not possible with the, which was not possible with the mailboxes, but through TLM it will happen. Okay, through mailbox I need to separately declare a mailbox for this and separate mailbox for this. Here with the same single TLM, both will going to happen. Got it? Did everyone understood this? How a sequence is getting driven to the DUT?
Yes, sir.
So now let's see how the sequence is getting mapped to the sequencer. Now let's try to understand how this communication, that means how the sequence, the particular sequence is getting mapped with the sequencer. Let's see. Okay, let's see this second step. Okay, so now let's see. So there are two methods to map a sequence with a sequencer. We have two methods. I mean, two, not methods, those are two ways. Okay, first one is like through start method in test. Second, through default sequence in test. So these are the two ways we have to map a sequence with a sequencer. Okay, so now let's see how we'll use the start method. Okay, so first way is like sequencer. Okay, sequencer or sequence have a method called start. The start method is there in sequence base. Okay, UVM sequence base. UVM sequence base. In the sequence base, we have this start method. Okay, so what the start method will do is the start method is called. So if this relates to the sequence, right? So the start method should call on a sequence. Okay, the start method should call on a sequence only. Okay, because this is a method related to UVM sequence base. Okay, so now let's see the prototype of that. Okay, so that is UVM sequence base that was there in a sequence folder. Let's go to the UVM sequence base. There, just type start. So somewhere else, see, these are the things. Okay, wait for grant, send request, and wait for item done. So these are some things. So these two related to start item, these four related to finish item. So these two will going to generally happen in the UVM tick. So that is the reason instead of writing this separately, and we are directly calling this one. But if we want to implement it, for example, wait for item done, it's a user defined thing. So wait, these pre-do, okay, these are user defined things. So if you want to implement some code in this, you can use it. So in such kind of situation, we need to implement this separately. Okay, we need to implement this separately. Until then, directly go with UVM do macros. Okay, so next, start. So it is, first of all, it is a task, so it will take some time. Okay, next, UVM sequencer base sequencer. So the thing is like we need to provide the sequencer. So let's copy this one. Let's try to understand what and all are the things that was there in this. Okay, prototype. Yeah. Now let's see prototype of stack method. So the first argument, UVM sequencer base, I need to give a sequencer. So here I need to provide a sequencer. The second thing is UVM sequence base parent sequence is equals to null, parent sequence. So anyway, it has one argument. So that is the reason I am not giving any kind of things here. So I will skip this one. Okay. So if there is no parent sequence kind of things, it will by default it will take null. So even though if I don't give anything, it will take null. Okay. Next, int this priority is equal to 1. For example, if I want to set a priority for a sequence, so I will use this. So you may ask like where we will use this priority. There is a concept called sequence arbitration. Let's take like there are 10 sequences. There are 10 sequences that try to access the driver at the same time. Okay. Then my sequencer work like an arbitrator. So which has the highest priority? My sequencer will allow that sequence to access the driver. So for such kind of situations we will use this priority. Okay, until then we won't use this. So if I don't give in the sense, it will take -1 in the sense default. The things -1 means default arbitration value set by sequencer. I mean, it was defaultly set by the sequencer, whatever the number it will be, because we are not at all interested on that at present. Okay. So this is bit call pre-post is equals to 1. If I put 0 here, pre-body and post body won't get called. Okay. 1 means pre and post body will get called. Pre-body and post body will get called. Okay. So if I make this 0 in the sense, it won't get called. These are the things. So that is the reason. So I won't at all, I won't use this at all. So the thing is like sequence based. This is an input. This is an input. Okay. So even though this sequence base, okay, whatever the sequence base is there, this is nothing but the parent sequence. I can write whatever the sequence I have, sequence seq, sequence and write and read. So all these are parent sequences. Okay. So if I don't write also, I'm calling this start method on the same sequence only. So that is the reason it doesn't make me any difference right now. Okay. So I need to give the sequencer. Next, that's it. Nothing more than that. Right? Did everyone understood this? Sequence dot start sequencer. That is how I need to give. Okay, so even if you want, we can write like this. Okay, let's take like 100 comma 1. This is the user defined priority. So if we are not at all interested in that also, leave like this, because all this has predefined values, right? It will take care of everything. So just write like this. It is exactly same as this, right? Did everyone accept this?
Yes, sir.
So now sequence, let's take like sequence write read instantiated as seq. Okay, inside test I have like this. Okay, next, so sequence dot start, I need to give the sequencer. Inside test I didn't have sequencer, so that is the reason I need to give the hierarchy. Got it? So this is the area where we have sequencer. Got it?
Yes, sir.
Yeah. So this is the first way. This is what we have done. We did this only, right? So in the test, we did that only. So what is the advantage of this is like this start method, once this sequence, all the sequence got handed over to the sequencer, okay, then my start method will tells like this sequence got completed. That is what the advantage with the start method, okay. So even if you see, you can get the same information from here also. So execute the sequence returning when the sequence has completed. So it will return when the sequence got completed. Okay. So next, the sequencer argument specifies the sequencer on which to run this sequence. So the sequencer must be compatible with the sequence. So that means my sequence is APB sequence. So I should not give AXI sequencer here. So this should be A. If this is APB sequence, then this should be APB sequencer. If this is AXI sequence, this should be AXI sequencer. Got it? Got it? If parent sequence is null, then the sequence is the root parent. Okay. Otherwise, if it is a child of the parent sequence, the parent sequence pre-do, mid-do, and post-do methods will call during the execution of that sequence. Okay. So next, by default, the priority of the sequence is the priority of the parent sequence. So if it is a root sequence, its default priority is 100. Okay, by default priority is 100. So a different priority made set by this priority, higher number indicates higher priority. Got it? So if call pre-post is set to 1, okay, default, then the pre-body and post-body task will get called before and after the sequence body is called. Got it? These are the 4 things. So default is like the default priority is 100. Got it?
Yes, sir.
So this is what a start method will do. Start method will do. Now let's see the second way. Second way is this is through default sequence. So this means we will run this default sequence at the sequencer during the build phase. So this will going to happen at the build phase. So till now we have seen all the sequence running and everything is in the test phase. I mean, sorry, run phase, right? So now let's start observing the things in the build phase through default sequence. Okay. So how we can do that is we can achieve this through config config database. Okay. So let's see how we will do that. Syntax. Okay. UVM config db hash UVM object refer. Okay. So I am setting a sequence. Okay. Set. So what is the things I am setting here? This I am doing this in the test. Okay. Test build phase. Okay. So who can access? Okay. Who can access sequencer? Sequencer run phase. Okay. So I need to specify this sequencer run phase. So that is the reason I am writing like this. Okay. Env environment dot agent dot sequencer dot run phase. So now I am redirecting this sequence to the run phase. Okay, run phase of sequencer. Now, what is the name? Default sequence. Default sequence. Okay. Next, the last one is what is the actual sequence I am trying to do? Okay, sequence, write, read, assume, sequence, and write, and read. Okay, and write. read scope resolution get type. So this is how we will set the default sequence in the run phase of sequencer. Okay, in majority of times we won't use this at all. Okay, because I didn't have much customization here. Okay, QUENC. So I didn't have customization in the sense I didn't have any control on this. Okay, I have a lot more control on the start method. So even if I want to change something in the sequence through test, that is possible here, but it is not possible here. Okay, so that is the reason we won't go with this. Okay, but I will show you like how to write and all. Okay, so for that reason I am taking one of the sequence. Okay, let's take like this. So a new test. Okay, test and write build phase or default sequence or build phase, whatever it will be. Okay, build phase. So test and read build phase. Yeah, so I don't want run phase. I don't need run phase here. So here what I require is function void build phase in function UVM phase. So here I am setting like the things are like in build phase of my base test something is happening, right? Environment creation is happening. So that is the reason what I will do is like I'll write super dot build. Okay, super dot build phase. If I don't write this, then for this test environment won't get created. If environment won't get created, agent won't get created, scoreboard won't get created. So scoreboard won't get created in agent won't get created in the sense sequencer driver monitor coverage won't get created, so it will throw an error for me. So that is the reason super dot build phase. So what kind of error it is? Fatal error. Fatal error will get created for will get uh, done for me with a kind of bad handle errors. Okay, so that is the reason we are writing super dot build phase of phase. Okay, so now I will write UVM config db hash UVM object refer scope resolution set. Okay, it has 4 arguments. So first arguments, who is setting? The present class, test and write and read build phase class is setting this. Who can access this? Sequencer run phase. Okay. Environment dot agent. Where is that? Agent. Okay. Agent dot sqr dot run phase. Run phase. Next. What is the name of this sequence? Default sequence. So what is the actual sequence? The value of the sequence. Okay. So sequence write read scope resolution get type. Okay. So now what happens here is this will return an object refer. Okay. This will return the type of the sequence. Type in the sense who is the parent. Okay. Who is the parent, what is the class name, what is the parent, and everything. This is a sequence, right? It doesn't contain any parent. So what kind of what kind of data type is this? So that will get returned. Okay, that will capture here. Okay, what it returns is it returns UVM object refer. So what is meant by UVM object refer is it is nothing but UVM object refer will refers to a class. For example, if I call UVM object refer on this class in the sense it is talking about test and write and read. Okay, test and write and read build phase. So this is the parent class of the UVM object registries or component registries. Okay, so it actually creates the classes. This is the component who creates the classes. Okay, that create method is there, right? based on the that create method will take everything will get taken care by this UVM object wrapper only. So now my sequence n write read scope resolution get type, in the sense my object wrapper came to know, okay, this is the type. So that means sequence n write and read is the type of the sequence. So now it will create an object and that was handed over to the sequencer automatically. Now, now let's try to run this one and let's see whether we are getting the outputs or not. Okay. So what is this? And write build phase. Okay. And read build phase. Done. So now I am running this test and write build phase. Okay. So now check this one. Test and write build phase. Okay, fine. So if we see, is there anything happening here?
Nothing, sir.
So what is the time the dollar finish is getting called?
Zero
Zero
nanoseconds.
0 nanoseconds. That means my test was not started at all. Objections was not raised. Objections was not dropped. Okay. Objections itself is not raised. Okay. If objections got raised and it is not getting dropped, in the sense it won't call the dollar finish itself. If it directly calls dollar finish and at the time 0 nanoseconds, in the sense objections itself is not getting called. Right? Did everyone accept this?
Yes, sir.
So now what we need to do is we need to raise an objection. So how we raise an objection? So generally we will raise an objection in the run phase, but here I am not writing any run phase. So where I can do now is like I will go to the sequence library. In the sequence library, I will raise the objections. So here I will raise the objections. So what I will do is, but to raise the objections, I require what I require to raise the objections. Where we raise the objections?
Phase instance we need.
The
The
phase.
task.
In the phase, we raise the objection. Yeah,
Yes, sir.
in the task only, we'll raise the objections on the phase dot raise objections, phase dot drop objections, right? So, but the thing is, sequences doesn't have base, a phase, right? Phase will be available for components only. Sequences doesn't have phases. I mean objects, because sequence is an object. So object doesn't have phases. So how can I raise the objections here? Did everyone understood my question?
Yes, sir.
So for that, what we will do is we need to instantiate UVM phase here. UVM phase, phase. I instantiated phase. Now I get phase. Phase dot raise objections. Okay. This now phase dot drop objections. This next phase dot set drain time. Phase done dot. Okay, fine. So I told like in the pre-body itself, I am raising the objections. After that, in the post body in the sense, by that time, this body will get executed, right? I am giving this sequence only, and write and read sequence. So if you see, I am giving and read sequence only. So once objections got raised, okay, once objections got raised, that is pre-body, right? Once the pre-body happened, Next, objections will happen. Objections raised will going to happen. Next, all this will going to happen. Next, post body. So objections will get dropped. Got it?
So here, this refers to which phase, sir? Run phase only?
This one. You are talking
Um,
about this, right?
yes,
So
sir.
this refers to base sequence.
Okay.
Okay? Base sequence or else whichever the class, because that will present in the sequence and write and read also. Right? That
Yes, sir.
this refers to sequence and write and read also. Okay? So wherever, whichever sequence that is getting called, that this refers to that particular class. Okay?
Okay, sir.
So now let's try to understand whether this will going to work or not. So address width, undefined variable width. So mem interface. Okay. So undefined variable UVM config DB, undefined variable near top address field line number 34. Class or package UVM root not found. Something is happening somewhere else. So that was indirectly or directly related to this, because this is the area when I changed the things, everything got happened here, right? So now let's see UVM phase. Mhm. Phase dot raise objections of this post body, phase dot drop objection this, phase dot set drain time of this. Okay, comma 100. Okay, there is a syntactical error. So now let's see what is the time it is ending now. What is the time it is ending now?
0, sir.
0 nanoseconds. That means whatever the code that I am actually writing here, like raising and drop objections, it is not taking effect, right?
Yes, sir.
Yes,
So
sir.
that why it is not getting raised. If it is, if it got raised, in the sense it need to know what is phase. So if it doesn't know what is phase, then it won't get able to, it won't raise the objections. So when will raise the objections? If it is, it raise the objections during runtime, right? So now at least I need to understand what is the value of this phase. Okay, so right now if I go here, just I will check like this. If phase is equals to none, I'm just checking like this. Okay, dollar display phase is returning null. Let's check this one. Okay, do I am getting that message or not? So now let's see build phase successfully, some elaboration, run phase, report phase. So am I getting that? So that means phase. So let's see, do we have that message? No, there is no displays, right? So for that, what I will do is, like, instead of dollar display, this is the problem with this. Okay, so tick UVM info test phase testing. I'm just writing like phase testing. Okay, UVM info. Sorry, UVM none. So now check this one. So do we get anything called phase? No. ID, by ID itself I can say this is not getting printed. Okay, this is not getting printed. That means this is not happening. This is not happening. Let's say phase not equals to null. Let's run this one. So do we get that? No, that is also not getting happen. Right? If you see, that is not getting happen. That is not happening. So that means what is happening here is this is not getting happen. So if this line is not getting happened, in the sense, let's make like this. If this line is not getting happened, in the sense, by default this task is not getting called. Okay, whether it is null or not equals to null, this line is not getting happening. So that means this is itself is not getting called. That means by default this sequence itself is not getting executed. Okay, so if it got called, in the sense, by default first it will start executing with the pre-body, but the thing is it is not executing that. So that means I need to do something to get that phase. Okay, so now what I will do is, here I am giving like agent sequencer dot run phase. So under the sequencer of run phase I am running the default sequence. Spelling mistake. Okay, this must be necessary. Okay, let's see. Then only it can able to understand what is that sequence is. Okay, that is the name, default sequence. So now if you see, phase is returning null. Got it? Phase testing, phase is returning null. Got it? So what I did here is like there is a spelling mistake here. So now let's see. Phase is equals to null. If phase is equals to null, I am telling that phase testing, phase is returning null, UVM null. So that means I am not getting any phase. Did everyone understood this?
Yes, sir.
So now I need to do something. I need to do something, okay, to get this phase. So how I can get this phase is, there is a method. Okay, phase is equals to get starting phase. Now else, just put like this, and if phase not equals to null, if okay, so I am raising the objections. If phase is equals to null, I am returning this one. Else I am returning, else I am doing the raising objections. Okay, here also if phase not equals to null, drop the objections and set the drain time. Okay, so now let's see. Now let's see. So else syntax. What is happening here? Okay, get starting phase, fine. If phase is equals to null, okay, this one is happening, else this one is happening. So what is wrong?
Sir, semicolon,
You
sir.
can info
Where?
Line number 15.
in your
Oh, okay. Sorry. Thank you. So actually when I put that semicolon, it is actually terminating that entire if else condition. Okay, so now if you see, I am getting all the transactions, right? If you see here, we'll get those things. Got it?
Yes, sir.
So this is called default sequence. Okay, so default sequence, actually the concept of this default sequence is taken from OVM. Okay, OVM. So what we can do here is we can use this default sequence and to set the sequence for the scheduled phases. Okay, for the scheduled phases, the thing is like you need to write this default sequence with the exact name. If there is any spelling mistake happens, it won't treat it like a sequence. Okay, this was taken from OVM. Okay, got it? Did
Yeah.
everyone understood this? So now what I am trying to do here is I am I am telling that we need to run this write n read sequence, n write read sequence on the run phase. So whenever I will try to write like get starting phase, now what happens is like my phase is getting run phase of sequencer. Okay, so this will get that run phase. So whatever the phase we have written here, this phase is taken here. Okay, so now it is checking if phase not equals to null, raise the objections. Okay, so next, if phase not equals to null, drop the objection. Got it? Got it? To check that phase is equals to run phase, we are writing this one. Okay. Got it, guys?
Yes, sir.
Yeah, that is what these things are all about. I mean, sequencer sequence mapping. So once that sequence will goes to sequencer, from the sequencer that request is given to the driver through TLM port, through sequence item port. Driver will drive that to DUT, and driver will update a response or without response to the sequencer. So based on that, if response is there, my sequence will collect that response. If there is no response, it won't do this. So this is how the things are going to happen. Okay, even I have a lot more steps here. Okay, I can represent a lot more steps here. Wait response, I mean wait for grant. Okay, send response, then send request, not response, send request. Okay, so after that I can wait for the item to get completed. Okay, wait for item done. So all those things methods need to apply here. Okay, so the thing is like I am not making it too much complicated right now, so that is the reason I am just not mentioning all those things here. So the basic understanding is like this step 2, how this step 2 will going to happen is like with the help of either start method or with the help of default sequence. Got it?
Yes, sir.
So if I want to do some kind of coding, like I need to implement it manually, then I will go with the kind of wait response. Wait for the these things like wait for grant, sequence, send request, or wait for the item done. These kind of things. Okay. Except send request, the remaining two are tasks. Okay. So there I can do some coding, user defined tasks. Okay. So that is what the ways are like. Okay. Any doubts here? Any doubts in sequencer sequence mapping? Any doubts here?
Hello, sir.
Yeah.
Sir, we write super in constructors. So,
Where? Super
super dot.
How can
super dot build phase.
Yes.
You're talking about that? Okay. This
So
one?
why we
Okay. So now tell me, is this child class or parent class?
Child class.
This one.
Parent class.
So now assume there is no this line. What will going to happen?
We are
So it
setting
will work, no sir?
No. The thing is like the parent build phase is getting overridden with the child build phase. Right?
Okay, sir.
In the build phase of parent, what is happening? This is the parent base class. In this build phase, what is happening?
creating the memory
Memory
for the
creation.
environment.
Memory
For
creation
what?
and
For what?
Environment. Environment.
environment.
Environment memory creation will happen. So now this will get overridden with this one. Okay. So I am telling that under environment there is agent, under agent there is sequencer, under sequencer there is run phase. Environment memory itself is not created. So will they create all these things?
No sir.
Then what will happen? It will return bad handle reference.
Yes.
Right? So let's execute this one. Okay. Only this got created. There is no components that got created under this. Okay. Why? Because there is this line, I mean this piece of code is overridden the base method. Their environment is getting created. That was not created now. Got it? Now what happens is when I write super dot build phase, super refers to this or this one. Super refers to. In line number 143, super refers to which class? Base test, right? Under base test, I have build phase. I am calling that here. This is a function call. So what is that? Under base test, I have build phase. So now these two lines will get present here. Got it?
Got
Yes.
it, sir.
Now run this, you will get the outputs. So matches 5 with all the monitor and driver is giving the inputs. I mean, monitor and driver is getting sampled and there is no errors. Okay, test passed 3 times. Fine. Okay, so any doubts? Any doubts in this?
No doubt, sir.
Right? Okay, so can I proceed to the next concept?
Yes, sir.
So sequence layering. So what is meant by sequence layering? What you understood from this, guys? What you understood from this two words, sequence layering? Guys, any rough guess?
Multiple sequence we call.
It is almost all similar. The thing is like with the help of small sequences, I can create a very big sequence or a big sequence. So that is what the layering means. Okay. I can create a kind of sequences in the form of different layers. Okay. So if I club all those layers, that will become a big sequence. Got it? So
Yes, sir.
we will create a big sequence using small sequence. I can't create a big test using small test. Okay, I can't merge 2 or 3 tests, but I can merge 2 or 3 sequences to create a new sequence. Got it? Remember this point. Note. We can't able to create a big test from small tests, but we can create big sequence, okay, using small sequences. Okay, so remember this one. Okay, so how can we do that? So let's see a syntax for this. Okay, so for this we need to understand what is UVM do macro. Okay, right now let's not go into the deep of UVM do macro. Okay, there is a separate topic for this UVM do macros. We will discuss that what and all are the things that a UVM do macro can do. Okay, so it can, so whatever the things just now we have discussed, right? Wait for grant, okay, pre-do, mid-do, okay, next start this one, like send request, okay, next wait for item done, okay, post do, all these things will get called one by one. Okay, so that is what a UVM do macro will do. Okay, so some of them are like tasks, some of them are like functions. Okay, someone will call automatically, someone will and like for some of them, if we want, we can do the coding kind of things. That is what UVM do. By default, it will call automatically, no need of any user intervenence on that. So now the thing
Sir,
is, yeah.
sir, can we do like we create new class and we take that test cases class instances and do operations further
Can you repeat?
to call the multiple sequences
Mm, mm,
to create the new like new class
mm.
and take the instance of the before we created the test cases class
Okay.
and do operations for that like
Two
it will happen.
operations in the sense, what happens there is previous test case in the sense that test case, if you do the instance, what will happen? It will just create an instance. Okay. After that,
Yes,
what we need to do, you need to call every time with the XMR, or else it won't work, right?
yes, sir.
Or else it won't work. But if it is an extending from another class, if that works in the sense, that extension also will get work here, right?
Yes, sir. We can take extents from base test.
Extends from base test. If you want to get something from the previous test, let's assume, okay, then instead of base test, extend it from previous test only.
Yes, sir.
So then the previous test content will present in my present test. So if there is a run phase on the test, what we need to do in the present test, super dot run phase of phase, I need to write like this. Okay,
Yes, sir. Yes,
but I can't able to inherit, I mean, I can't able to inherit more than one test, right?
yes, sir.
But in sequence, I can use multiple sequences to create one big sequence, which is not present in the, which is not possible with the test. That is what I'm telling. Okay.
Okay, sir. Got it.
Yeah. So now for this, we will use, to create a bigger sequence, we will use a macro called UVM do. Tick UVM do. So now let's see what is this tick UVM do, where this macro coming from and everything. Okay, so this is coming from macros. So this is actually an object defines. So now let's see, not object defines. Yeah, UVM do. No, it was not there here. So now face. No, not face. UVM do. It was not there here. So it was not printer. Reg TLM defines version sequence. Yeah, yes, here it is, UVM sequence defense. Now here we need to provide two things, either sequence or item. Okay, I can give anything, either I can give a sequence or I can give a sequence item. Okay, that is what this is telling. This macro takes as an argument as UVM sequence item variable as an object or object. Okay, so in one word we need to say I need to give a object here. Okay, so what it can do is like it can do these many things. Okay, UVM create. Okay, next wait for grant, pre-do, randomize, mid-do, request, wait for item done, post-do. All these things will get done. Okay, so we will discuss these things once we'll go to the UVM uh, do macros. Okay, so for right now, just what we need to understand is like what and all the arguments that this UVM do will access. Okay, so UVM do will will accept either UVM do will accept item or a sequence. Okay, so after that it will take care of that randomization and everything. So randomize call is happening in that only. So that is the reason I don't need to take care of everything. It will taken care by this only. Okay, so for that what I will do is I will try to do one thing here. Okay, so what I will do is I will go here. So I just wrote sequence write read, sequence and write and read, sequence write. So there is no sequence read, right? So what I will do is I'll go here, sequence. I'll call this as like sequence read, sequence read. Okay. Next, I don't want this one. Is equals to 0. Okay, now I'll create one test. Okay, so basic we have a test right. So now what I will do is like I'll create one more this call test call test read. Test read. Okay, so what I will do is like I'll remove all these comments. Okay, yeah, now raise objections start. Okay, now what I will do is I'll run this one. Okay, I'll run this one test read. Okay, so here test write test read. Okay, we know we already saw that test right. So now I will do test read and I'll just observe like what I will get here. Okay, so why I am doing is like to create a big sequence from the small sequences. Here I have two sequences, one is sequence write and sequence read. So these are small sequences. Okay, so let's try to do that. Okay, so if you see I am what I am reading here. So address 1. So address is getting 1 and the data. So it is not generating any data. So because our data, there is nothing there in the memory list. If you go here, this is my memory. Open that, there is nothing there in this memory list. Okay. So that is the reason it is not giving me any data. Okay, so even that, for that matter, writes are 0 and reads are also 0. So that is the reason my scoreboard is doing like a pass check, because if we go here, W data is 0, R data is also 0, right? So that is the reason it is giving such kind of things. Okay, so now what my intention is like, here in the sequence library, so I will create a sequence. Okay, so how I will do that is, I will create like this sequence. I'll create the same sequence. Okay, sequence write read, sequence layered write read. Okay, so layered write read. Okay, so now instead of this one, I'll call UVM2. So I don't want this at all. It want only the sequence names. Okay, seq underscore write. Okay, this is read. Okay, got it? So,
Yes, sir.
so what I did here is, now there might be a chance that I won't get proper scoreboard pass or something kind of like that, because it will randomize some at different address, this will randomize some different address. Okay, so that's fine. Or else what I will do is like, here I will set that address as well. Okay, request dot address is equals to, okay, free. Okay, here I am setting that request dot address is equals to, this is address underscore I guess. Yeah, 3 semicolon. So go here and update that as well. Now what happens is like, now I get a proper thing. Now what happens is like, whenever I call sequence layer write it, in the sense, first it will do sequence write. Once this got completed, next it will do this one. These two will going to happen on the single sequence called single sequence layered sequence. Okay, so now go here, test write it instead of n write it. Yeah, I'll go here, I'll take this one. So test layered write it, layered sequence write it. Okay, so now layered sequence write it, here sequence layered write it, layered write it. That's it, done. Now let's go and call this test. Okay, now I am calling this one. So something is happening. Let's see what is that. UVM do. Okay. Okay, fine. So the thing is like, I didn't instantiated that. Okay. Sequence right, seq1. Okay. Sequence read seq2. So now it doesn't know what is that sequence write and sequence read. Okay. Now it will look. So you may ask like, you are not creating the sequence, how it is happening? How it is happening? If you see, match 1 happened. So write is going to happen at address location C, DCB0. So 3 DCB0. During read, write it 0, 3 DCB0. So driver is also writing in 3 DCB0 and write it is equals to 0. So in the wave also we can able to see those things. 3 dcb0, 3 dcb0. This is right rate. This is right rate is equals to 1, right rate is equals to 0. Then you may ask like, you instantiated but you didn't created the sequence. How the sequence creation is getting happened? That is what UVM do will do. There is a macro called UVM create. First it will call that macro. That macro will use factory to create this sequence. Okay, got it? So if you go here, first UVM create of item. So here we are giving sequence. So now what happens is that first it will call the it will call the factory method, and it will create the create method there. Okay, it will use the create method, and it will create the memory for that. Next it is waiting for that grant. So some pre-do before randomization, after randomization, before sending to the driver. Okay, sending request. So once request happen, so it is waiting for the item done. That means driver need to tell to the sequence of that item done. So it is waiting. So once it was done, the post to. So something after getting the things. Okay, so these things is actually happens here. Got it? This is what the things that will going to happen, in the UVM do or UVM do with. The UVM do with and UVM do difference is this randomization without any any inline constraints, that is called UVM do. If in with inline constraints, that is called UVM do. That is the only difference. Okay, did everyone understood this?
Yes, sir.
So that is what those things are like, UVM do, and somewhere here UVM do with. So this is same as UVM do, except that the constraint block in the second argument is applied with the item or sequence in the randomize with the statement before execution. Okay, so kind of things UVM do with like that. Okay, with the constraint, this constraint is getting added additionally. Okay, that UVM do priority with. So here we can set the prioritization. Okay, and constraints. So like that, UVM create on, UVM do on. Okay, so there are a lot more things are there. Okay, UVM do with, UVM do on with. Okay, so we will discuss this because this is UVM do on. So this is one of the important thing. Okay, so we will discuss like once we'll go through the UVM major things, like once we'll go through that UVM concepts, then we will understand like what these UVM do's are and everything, because there is a separate dedicated topic for this. At that time we will discuss all these things. Okay, so for this the only thing we need to understand is like how UVM do work. If we understand UVM do, how UVM do work, in the sense based on the UVM do only, the everything will work. Okay, directly or indirectly, the UVM do is actually getting called in each and every macro. Okay, like that. Did everyone understood this? The sequence layering.
Yes, sir.
So after that, if we want, we can also include this one. We can also include this sequence and write and read. Include instantiate here. Call that one. That's also fine. That will also get happen. So if you want, let's see that sequence and write and read. Sequence and write and read seq3. Okay, so call this one. This will do single write, this will do single read. Next this will do 5 write 5 read. So total 6 writes 6 reads need to happen here. Okay, so now let's see. If address 3 got generated in the third sequence, the data will get overwritten. Okay, matches 6. Okay, wave, if we go here, 6 writes 6 read. Okay, got it?
Yes.
Yes,
Yes,
sir.
sir.
So that is how the things are going to happen. Okay, that is sequence layering. Okay, UVM do sequence instance, or I can write sequence 1, sequence 2, task body, and task. So this is how a new sequence got created. That layered sequence got created. Okay. So any doubts in sequence layering? Any doubts in sequence layering?
No, sir.
Okay. So let's start with command line processor. Okay. So now we need to understand what is this command line processor. So actually UVM has a dedicated class called command line processor, okay, which will take care of the arguments given during command line, during the elaboration stages, or uh, that class will take care of the arguments that was given in the command line. Okay. So why it need to maintain a dedicated class for this? Okay. So first of all, why I require this one? Okay. Why I require this one? So for that matter, we need to understand one thing. Assume there are 10,000 files in a project. Assume there are 10,000 SV files in the project. Assumption. So now what happens is, assume you guys got deployed in a project. Okay. So now what happens is, once you go into the company, okay, so once you got alerted to the project, what you will do is, like, you will do a process called checkout. Okay. So checkout, in the sense, you will take the project from the central server to your personal laptop, in the sense, so they will give you one similar kind of servers. Okay. So from into that server you will get that whole project, a copy of whole project was get created in your local server ID. Okay. Then this is called check-in. So in that check-in, what you have came to know is, like, there are 10,000 files got checked in into your laptop, okay, in your personal server, in the sense, in the server allotted by the company. Okay. Now what happens is, you are trying to do some changes. Okay. You did some changes to some files, say three files Now if three files got changed, assume if three files got changed, in the sense, what does that mean? What I need to do then? If I do any changes, in the sense, what is my first step to run? While running, what will be the first step that will going to happen if I do any changes?
Compilation.
Compilation. That means three files need to get compiled, right? And there are some files that depends upon these three files also. There is a possibility, right? Some of the codes got called there might be also some chances, right? Let's assume this three file references are was there on 20 different files, assume. Okay. Okay. That 20 different file references is there in 100 different files. That 100 different file references is there in 1000 files, assume. So that is how the dependencies are there, assume. Now what happens? All the files need to get compiled, right? Did everyone accept this?
Yes, sir.
So assumption just for compilation, it took 10 hours. It took 10 hours of time. Okay. So now what happens is like I did everything. Compilation happened for 10 hours. Elaboration happened for 23 hours. So just to observe the output, okay, I wantedly waited for more than 1 day because elaboration happened. After that, run need to be happen, right? So it will take time. So automatically, I need to wait more than 24 hours. In my case, did everyone accept this?
Yes, sir.
So that means a small change, even if you put additional semicolon also, then that file need to be get compiled. So that means it will cost me more than 24 hours to get the output, right? Did everyone accept this?
Yes, sir.
So now what I did is, now I directly go to the top module, and inside the top module there is an initial begin. Inside that initial begin there is a run test method. Inside that run test method I changed the argument. Now what happens? Now what happens?
Again, compilation happen and elaboration.
That means I need to wait another 24 plus hours, right?
Yes, sir.
So the things are like, this is causing the unnecessary time waste for me, right? Right?
Yes, sir.
So how to reduce that things? That means I can save the compile time, because if once the code got successfully compiled, until a real change happens, that means until a necessary change happens, I won't recompile that. For example, there is a big error happened inside my test bench, and that requires an update. Then there is no other option for me. I need to do that update, and I need to wait for the 10 hours for compilation. There is no other option for me. But if there is no bugs, okay, if there is no bugs, but I am using the arguments that was there in the code, I am changing that codes manually. I am changing the code manually. So if I alter the code just to pass the argument kind of things, then is it fine for me to wait for 10 hours just for compilation without any errors? That means I am recompiling again and again for 10 hours for every test case. Is it fine?
No, no, sir.
No, right? Because it is not like 5 minutes or 10 minutes. It's a 10 hours, right? Who will going to wait for 10 hours, right? So now what happens is, that is the area where UVM came up with a class called command line processor. So it has lot more commands. Okay. So some of them are used for the global test bench, the entire test bench. Some of them are used for the dedicated file. Okay. So such things are also possible. So there I can pass that through elaboration. So plus UVM test name is one of the command from the command line processor. Okay. So what this command line processor will do is like, it will use dollar value dollar plus hearts only at the end of the day. Okay. So it will fetch everything, whatever that was written in the elaboration argument, and it was hand over to the respective class. For example, UVM test name. It was required by the root. So it will hand over that to the root. Got it? So there are certain methods like set report verbosity. Okay, set report verbosity, set report ID verbosity, set report severity ID verbosity. So such things are there. Okay, so that will be applicable for a particular class. Okay, now I can change it instead of going and changing in the particular file. I can change it from the command line argument only. Okay, that intent save me the 10 hours of time. Did everyone got this?
Yes, sir.
So that is the reason UVM created a new class called command line processor, which helps us to save that time. Okay, so it has lot more arguments that we need to understand. Okay, we will mention that some of them, we'll mention some of them now. Okay, so before that, let's see. Okay, command line process, you did some changes to some files, 3 files, that then we need to compile the entire code. Okay, now this compilation cost me 10 hours, my 10 hours. Now if there is a real update required, then I will update the test bench and I will compile. Okay, but for just changing the arguments of a function or task call without any real bugs in test bench, do I need, is it fine for me to wait for 10 hours of compilation? No use, right? So to solve that issue, UVM created a class called UVM command line processor. UVM command line processor. So it will take the arguments from the command line and it will give that to the respective classes. So this is what a command line processor will do. Got it? Got it, guys? Any doubts in this?
No, sir.
Okay. So now let's see. Okay, some of the command line arguments. Okay. Some of the command line arguments. So the applicable are arguments with capital letters, applicable for entire test bench. Okay, for entire test bench. So let's see. UVM test name. Okay, test name. Okay, UVM test name. Next, UVM verbosity. Next, UVM timeout. UVM max quit count. Max quit count. Next, UVM phase trace. Next, UVM objection trace. Okay. UVM resource db trace, UVM config db trace, okay. So these are some of the command line arguments that, I mean, command line argument, I mean, these are some of the command line processor arguments that actually applicable for the whole test benches. So till now we have used these two things: test name, verbosity. So timeout, I can set the timeout. Default timeout is 9200 seconds. Okay. So max quit count. So I can say like what happens here is, if there are errors, assume there are certain UVM errors. Okay. If more than 4 errors or 5 errors, the entire, I mean, it will call the dollar finish automatically. So I can set this max quit count to 10, assume. So now what happens is, like, until the UVM errors becomes 10, it will wait, and once it becomes 10, it will call the dollar finish. Got it, guys? Next, phase trace. It will tell like which phase, okay, on which phase my root, actually all the components are now, okay, and all. Next, UVM objection trace. So which one raised the objections, which one dropped the objections, okay. Resource db trace, okay, who set, who read everything. Config db, who set, who get all the information, we will get, we will trace everything, okay, which component said that, which component read that, everything will be done here, okay. So let's see next one, arguments that was applicable for a specific hierarchy. Can be written in small letters, okay. So capital letter means that will be applicable for the whole test bench, okay. So that is the reason we are writing with the capital letters. If we wrote with small letters, that will be applicable for a certain hierarchy, it won't applicable for everything, okay. So let's take like UVM set verbosity, okay, UVM set action, UVM set severity, severity. Next, UVM set inst override, override, okay, UVM set type override. So like that, okay, okay, like these are some of the things where this will be applicable for a certain hierarchy, okay. So these are applicable for the whole hierarchy. So all these are from reporting classes. So these are from the reporting classes, and these are some of the uh, factory related classes, okay. So once we came to reporting class and factory related classes, there we will discuss like how to use this and everything, okay. So right now we're going to see this one, okay.
Hello, sir.
Yeah.
Sir, if you want to change the like user defined variable,
Mm.
like we are using mem common class as count variable like that.
Yes.
So we want to change that one.
Mm.
There is no command line for that.
There is no command line for that. We need to
So
use the
what we
dollar
can do,
value plus x.
sir?
We need to use the dollar value dollar plus x by our own, okay.
Okay,
There is
where
no
we are
other.
using SP.
So like these are some of the command line arguments, okay. Arguments, if we want to use our own argument, then we need to use dollar value dollar plus args. Okay, and we need to fetch from the command line. Got it?
Yes, sir. Yes, sir. Got it.
Count, which was not part of command line processor. We need to fetch it from fetched using dollar value dollar plus args, like that. Got it?
Yes, sir. Yes.
So now let's see where this command line processor and everything. It was there in the base. Okay. So here we can see CMD line processor. Yeah. So this is the command line processor. So it is extended from report object. Okay. So so command line processor m instance. Okay. It is a local variable. It is a kind of single instance. Okay. Lot more things happens. It is returning something. It is getting something. Okay. Lot more. The things are get arguments. Okay. Get plus args, UVM args, matches, a lot more things. Okay, so many of the things we don't need to go through this class also. Okay, but if you want a really good information from this class, in the sense there they have given like how we can use this class. Okay, they given like this. Okay, somehow we can use this one actually. Okay, so we can get some nice information from this as well, like UVM test name you can use like this. They are telling like you can write like this. UVM verbosity you can write like this. Okay, UVM set verbosity, this is in the small letters. So the thing is like we need to give the hierarchy. So how the set verbosity looks like, this is how the set verbosity looks like. So they have given one of the things. So what is the component name, where it is using, so who can on, I mean verbosity. Okay, right, so who can on access. Okay, so what is the verbosity for this particular, I mean under agent one, what and all are the components are there. For all UVM full is the reference verbosity. Okay, so and these are some time variables. Okay, so like that UVM set action, so I am setting an action. So what and all the things that was there under environment 0. So if UVM error came, so don't take any action. So I am telling that don't take any action. By default UVM error has count action. So if it have more than the quit max count, so it will automatically call the dollar finish. So what I am telling is like don't take any action. So that is one of the things. Next, timeout. By default it is 9200 nanoseconds, sorry, 9200 seconds. If we want to give our own value, so we can give like this, plus UVM timeout is equals to some time. Okay, got it. UVM max quit count, if you see I can give some count here. Okay, so plus UVM max quit count is equals to 0. Okay, so phase trace, so it will return like what and all are the phases that was going through each and every uh, component. Sometimes what happens is like it will get stuck in some of the phases, then we can able to trace that and we can able to understand like what phase the present component is. UVM objection trace, so who is raising the objections and who is dropping the objections. Resource DB trace, so who is setting, who is getting. Config DB trace, who is setting, who is getting. So like that, set instance override, type override. So this is how the things are going to happen. So what is the packet, I mean what is the class and which class need to override. So right now we didn't discuss about all these things. Okay, set instance override, set type override. So that is the reason I am not going through this. Okay, so the thing is like here I can set some configuration into variable or kind of things, kind of string variables kind of things. So for that I can give such kind of things. So which is right now it is not relevant for us. Okay, right now it is not relevant for us, so that is the reason I am not discussing here. Okay, so once we discuss that respective topics, then we can go through all the things. Okay, these things. till here. We can work till here. Okay. So let's try to understand what these things are like. Okay, so we know what is UVM test name. So we know what is UVM verbosity. This is the reference verbosity. So let's try to work on those things. Okay. Okay. So go to the run.do. So all these things need to be included in the command line. Okay, so plus UVM verbosity is already there, UVM verbosity is there, test name is there. Next one is test name is there, verbosity is there, set verbosity. Don't go with the present these things. Okay, set verbosity, set action. Okay, don't go into that, the small letters, because those are all related to the those are all related to reporting classes. So UVM timeout. Now what I will do is like to observe the UVM timeout for one of the test case. Let's assume what is the test case I am doing. Uh, let's take like set right. Okay, so I am doing the set right. Okay, so right test case. So this is the right test case. Inside that, what I am doing is like I am not dropping the objections. If I am not dropping the objections, in the sense it came to so my root won't proceed to the next phase. That means my simulation will going to end at 9200 seconds. So for that reason, what I will do is like I'll write plus UVM timeout. Timeout. Let's take like 1000. So next. So let's see. So 1 microsecond. Right. 1000 nanoseconds. Right. So that is 1 microsecond. So that is what the things are like. Got it? Grid time control. Go to nanoseconds. 1000 nanoseconds. Dollar finish will get called automatically. Dollar finish will get called automatically. Got it? So if I don't write this one, assume if I don't write this one, now let's see the same test. See, it is never getting ended. Counting the times. So it is continuously to be get counted till 9200 seconds. Now we are in the nanoseconds range. Got it? We are in the nanoseconds range. So that means we need to wait for a lot more time. Okay. So that is the reason. If anything such kind of things happens, go with UVM timeout. Okay. Got it, guys? So sometimes this will create an issue for me. If I give the timeout, in the sense, what happens in the sense, maybe at the 1000 nanoseconds, even the sequence is getting run, it will end the simulation. So that is the reason I removed that. Now let's see next one. Max quit count. Okay, plus UVM max quit count. Count is equals to, let's take like 10. Okay, so now what happens is, until this got executed for 10 times, until this until we got 10 UVM errors, it won't end the simulation. Okay, so now let's create such kind of situation. Okay, so what I am trying to do here is, so yeah, what I will do is I will try to do UVM error. I am trying an UVM error. Okay, so I am wantedly doing this. Okay, so driver drive transaction. Okay, observing the quit count, observing the quit count. Okay, so now what happens is I will go to common and I will go with 15. Okay, so and that too I will go with, so right now I am not using this one. Okay, hash. So I am going with write and read test. Okay, so now let's run. So how many errors? 30 errors. So what is the UVM error? Here we have an UVM error. So observing quit count. So why it is giving these many errors? Actually, 5 errors, I guess. After 5 errors, it need to get called dollar finish automatically. Okay, but it is happening for 30 times. Okay, so what we will do is like we will go for UVM max quit count is equals to 10. Okay, UVM errors 10. If you see, after 10 UVM errors, it got ended at 190 nanoseconds. Previously, it got executed for 30 times, right? Quit count 10 of 10. Got it? Quit count reached. Got it, guys?
Yes, sir.
So that is how the quit count works. Basically, it it is like 5 kind of things. Why it is taking that many times? Let's see. Allows user to change max quit count for report server. The over yes or no specify whether user code can be subsequently changed the value. If said to no, the user tries to change the max quit count value. Okay, and warning message will get displayed. Okay, fine. Plus UVM quit count is equals to 5. No, so here they are telling like I am not interested to change. I mean, even if you're trying to change and put no in the sense, it will give a kind of warning for me. That's fine. But what is the default max quit count value? Let's see, it is like 5. Whatever I remember, it's 5 or less than 5. UVM basic quit count value, max quit count value, not usage. Yeah. After 5 errors, basically these 5, Basically 5. Yeah. Max quit count allows user to change the max quit count. So we know this one. Yeah, this is the information from the LRM only. Okay. Okay. So okay, fine. Let's not spend too much time on this. But it is happening, right? If I give some value, it is holding till then. Once that many errors happens, automatically the simulation is getting terminated. Yeah, that is what the purpose of this UVM max quit count, and that is serving fine. So that is what we observed. So let's see without this one. Okay. So UVM info 85, UVM errors 30. I'll go through this because it should not take all the errors. It should end. Maybe after simulator update or something kind of that, it is happening kind of these things. I'm thinking so. Because it should not move more than 5. Okay, it should not go more than 5. Okay. So what I will do is tab new run.sh test write read. So now I will run this one. It is the dump. Okay, fstp dump tcsh source home tools synopsis cshrc synopsis chmod plus x run.sh run.sh. Okay, still here also it is taking 30 errors. Okay, so I will go through this because driver transactions 30. Maybe in the latest alarm kind of things they got updated or things so. So I will go through this and I'll let you know why it is happening, because it has, it won't take what and all the errors are there. So it has count. That count can reach as the maximum value UVM count. That is what action calls. So once that action got called, in the sense, once that action got received, in the sense, it need to end the simulation. Okay, I will look into that and I'll let you know what is happening here. Okay. So okay, fine. So now let's see the next one, UVM phase trace. Okay. Plus UVM phase trace. Like it will tell like what and all are the phases that a component is going through and everything. If any component struck somewhere else, it will tell me like, okay, this component is there in this phase kind of things. Okay. So this is how the detailed information it will give. Okay. So let's go and see. So from here the actual simulation got start. Okay, so now let's see test and write and read. So phase common, starting phase, completed phase, all this happens, and build phase of environment got happens, and all these things. Then reporter phase ends, kind of things. Next scheduled, everything happen. Next connect phase is getting called. Okay, next connect phase, and it is going through all the phases of connect phase, and it is ending the connect phases, and it is actually starting the end of elaboration phase. Okay, so next starting phase, so like that it is printing everything. After that it is going a common dot end of elaboration phase dot completed. So this common dot end of elaboration phase, this is coming from the common phases. Okay, so that is coming from the common phases. And reporter, okay, reporter is actually doing this. Okay, so this reporter, it is one of the UVM class. Okay, so that will actually going through that. Okay, next, so ending phase. Okay, so next base phase dot common end of elaboration phase, this is the ending phase. Okay, next end of elaboration that was got completed. Okay, so next schedule from the phase common end of elaboration phase, that means common dot start of simulation phase is getting started from the phase of common dot end of elaboration phase, telling that end of elaboration phase dot completed and start of simulation phase got started. Okay, so next start of simulation phase, that starting happening, and it is going through because we are not doing anything inside that, right? So that is the reason all these are like starting, ending, all the things are happening simultaneously. Okay, and that too, all these are functions, so starts, ends. Okay, so now here, so it is in the run phase. So one run phase happens here, we are giving, here we are using, so run of score, run phase of scoreboard happen, run phase of monitor, driver, coverage, and everything got happened. So now it got entered into the scheduled phases. Now the different scheduled phases, all the scheduled phases, whatever the things that was there, the 12 scheduled phases, it is going through the 12 scheduled phases. So reset got completed. Now once reset, I mean pre-reset, post reset, and reset, all those got completed. Next it will go to pre-configure. Now it is actually, it is giving all the information, like we are going through these phases. Okay, so it is giving me all the things like, okay, these respective phases gone into that, and these things are ready to skip and all. So pre-main, main, post main, after that pre-shutdown, shutdown, and post shutdown. Once this got happened, post shutdown, next at that time these things happens, so it is getting print. By that time the driving happens and everything. So once that got happened, all these prints is going to happen. Next, by this time the run phase got completed. Okay, it is proceeded to the extract phase. So extract phase, that is from phase common calling ready to end. Next shutdown phases got completed. Now it is going to all the UVM schedule phases got completed here, and it is going to the extract phase. After that, from extract phase, it is going to check phase. So in the report phase, I am getting this information. Okay, so next phase, I mean the the final phase is getting called. So once final phase got called, UVM and this dollar finish is getting called automatically. So that is how the things is going to happen. This is what the phase tracing means. So it is giving like what and all the phases that was going through, what phases that was happened. If it got struck somewhere, it will show like, okay, it got struck here in the run phase, in the main phase of the run phase, it got struck. That means we need to figure it out, like this sequence is happening at that particular area. So that is the reason in that particular sequence there is something issue happens, kind of things. Did everyone understood this?
Yes, sir.
Yeah, so like that we will do.
Sir,
Okay, yeah,
sir, can we take 5 minutes break?
actually I'm ending the session. Okay,
Okay, sir.
okay then, yeah, we'll meet tomorrow. Okay, yeah,
Thank you, sir. Thank you.
yeah, thank you guys.
This conference is no longer being recorded.